Okay, so we're going to start kind of where lecture left off. I'm going to be talking a little bit about demo, I guess. Just with a dart gun, nothing doesn't hurt it. It's not a bullet or anything. It's just a small little tranquilizer. So first thing, two-dimensional versus one-dimensional vectors are fairly easy to go from one to the other if one vector does not depend on the other. You can it's like doing two completely separate vector problems, one in the x direction, one in the y direction. They don't depend on the other. It really doesn't matter. As long as your final answer supports both of them, it's fine. The only thing that they share is time. So you can actually figure out the time in the x direction and plug it into the y direction, and it should still work fine. Chapter 4 has several different types of problems. I'm not going to be going over all of them, but maybe next week I'll spend some more time on some of them, since Chapter 4 is due next Friday. And we'll also get to Chapter 3 questions, if you have any of those questions. But Chapter 4 has two-dimensional motion with constant acceleration, which is what he was doing today. Projectile motion, he was also doing today. And then particle and uniform circular motion, tangential and radial acceleration, relative velocity, and relative acceleration, which I assume he'll get to later, so I won't cover those last three at all. But the strategy to solve these problems are the exact same as what I went over last week. Conceptualize, categorize, analyze, finalize. Exact same thing. It's just a different type of physics problem. So make sure every time you start a problem, ask what is happening. Make sure you understand what is happening. Don't just assume that you understand and just start the problem. Make sure that you have all the facts before you start it. Then you're going to categorize it, meaning you're going to make assumptions. You're going to say, well, what is gravity? Gravity is negative 9.8. That's an assumption. You've already made an assumption. You're categorizing it as a constant acceleration. So make sure that you at least think about it a little bit. Don't make poor assumptions or wrong assumptions. Make sure that, you can almost always make the assumption that gravity is going to be negative 9.8 unless otherwise told. But just be aware of that. Okay, then you're going to analyze it. I solve everything symbolically today. We can put numbers in if we want, but once you have it solved symbolically, there's really no reason. You're done basically, except for the final answer. And then remember to finalize. Ask yourself, does this answer make sense? So if we were doing shoot the monkey and you got an answer that it would take an hour for the projectile to hit the monkey, that is just wrong. And you have to think this is wrong. Don't just say, well, that's the answer I got, so I'm going to stick with it. I really doubt Jason will have any sort of problem that does not make sense. Yeah?
So basically think realistically.
Think realistically, yes. There will be, I will caution you, there are some times where people who write problems in the textbook will not think realistically, and there will be problems that might not quite make sense, but I doubt Jason will assign any of those. But if you're doing some on your own and you encounter some of those, it's possible. I know I had some when I was doing this class. Okay, so the lecture portion of this recitation is going to be fairly short. Jason didn't give me anything really to cover. But what I wanted to go over was the drop the monkey. So my monkey is going to be a spherical blob with a face. That's my monkey. The best thing to do is to define where the projectile is coming from at 0, 0. Always at the origin. This is your y. This is your x. If it is not done for you, just define it there. Maybe one question will say, okay, it's shot from a location of 4 meters up, 5 meters, something, something. Move the position where it's launched from to the origin. That might be somewhat difficult. That might be talked about in a later section, but you can actually move it because they're vectors. Vectors you can just move wherever you want. So if you know the distance between where it's shot and the monkey, you can just move that whole thing. Okay, so now that we have our tranquilizer gun at the origin, we learned that you have to aim at the monkey because the bullet or projectile, won't use bullet, will travel, assuming assuming no outside forces, meaning no gravity, it will go directly towards the monkey. But that's not the case. The case is that there's gravity. And so the monkey drops out of the tree. I'm not going to even attempt to draw a tree. But he jumps out of the tree, and he doesn't push himself off, so it's free fall. So the exact same thing's happening with the shot. So somewhere it's going to start to fade. If you shoot it somewhat fast, it will hit just a little below. If you shoot it at like a medium speed, this is supposed to be arced, it will hit lower. And then what we did today is we actually hit it right as it was hitting the ground. Right there. It was at the ground. They hit it like the exact same time. Know that there are theoretical instances where this could be false. So you can't hit the monkey past the ground. You might have setups in which theoretically you could, but physically you can't. You can't. The monkey's going to stop at the ground. The bullet's going to stop right here. They're not going to collide. There's going to be this instance where you didn't shoot it far enough, so they didn't physically hit. So make sure that you separate the physical and the theoretical. I don't know if Jason's going to ask something like this either, but I mean, he could say, what if the velocity was this? At what time does it hit the monkey? Well, the answer would be it doesn't. It hits too short. So be aware that even if the solution exists, it won't be a physical or a real solution. Okay, so now we're just going to jump into the problems, which means that we should have a good chunk of time for questions afterwards, because I only am going to do a few of these problems. But the biggest chunk is deriving all the equations. Now, he derived a fairly good amount of them during class, but he didn't finish what they equal. He almost got there. It was like one more line. But if we're thinking about the shoot the monkey, I guess I can draw it up again. We have the monkey. We have the projectile. So the projectile will be P. Monkey will be M. This is initial position, initial velocity right here. So this is velocity initial of the projectile. I think he uses the O instead of the I. So I'm going to try to keep it as similar to him as possible. This is the initial. This is initial position. Make sure I have my vectors. Initial position of the projectile. This is, so initial position of the monkey. I think in the notes he used squirrel because it was like kind of like a squirrel thing. But you can use whatever indices you want to make sure that you understand it. Okay, now the things we know. This is going to be the distance between, in the x direction, this is going to be the height of the monkey. I'm going to do it all symbolically, so I won't. He was putting in guesstimations. He was thinking, oh, this is about 4 meters away. It's about 0.8 meters up. I won't do that. I'll just do it all symbolically. So first off, the acceleration of the particle. There's no initial. We're assuming constant. So constant acceleration. This would go under our categorize. So constant acceleration. That's just gravity. There's no acceleration in the x direction. So no I hat acceleration. So 0 I hat. I'm going to define gravity as negative 9.8. So I can write plus. So plus g j hat. Yeah, that's the only thing for the particle. The only acceleration it feels is in the downward direction. This is the exact same for the monkey. 0 I hat plus g j hat. Okay, so we have our accelerations. That's the only thing that's changing in the velocity, meaning that the x direction is not changing either, or acceleration-wise. I guess the velocity that's initial in the x direction will be the same throughout the entire thing. So velocities, velocity of the particle at any time t is going to equal the vector the initial t plus g, not a vector because it's only j hat. Actually, let's do acceleration. So acceleration mt. And gravity, it does not change with respect to time. So that's the, oh, not mp. They're the exact same. So this equals am. So they're interchangeable, but let's try to get the indices correct. This is a vector. If we divide it into different, so there will be two ways that he will give a question. One, he will provide you with the components, which is easier, or two, he will provide you with the magnitude. And so you'll have to know the angle. So a way to do that is you'll have the magnitude of the initial velocity. You'll have to either figure out this angle. Probably d and h will be given, I'm assuming. There's lots of different ways you can do this. But I'm gonna assume that we already have the components for velocity. So that means that this is x direction. Actually, I don't even have to put x, because it's going to be I hat. No, I'll put x. T I hat plus v y t j hat plus g j hat. So that's the velocity of the particle. Has the components of both x and y, and then the gravity that t j hat. Okay, I think that's right now. So I just plugged in this for that. Okay, then the monkey equals velocity initial, which is 0. So there's no initial velocity for the monkey. However, no, I won't. No, I'm gonna put it at 0 later. V. Nope, monkey. M plus a monkey t equals v initial x t. These indices are crazy. M I hat plus t j hat plus gt j hat. Okay, so the point at which the projectile touches the monkey will be, vector, when r monkey t equals r projectile t. So what is rm and t? Rm t equals the initial position of the monkey, which is h, plus the initial velocity, which I'm going to leave in vector form because it'll eventually be 0 anyway. T plus am t, t Man, I'm making all sorts of mistakes. 1/2 AMT squared. Okay, I think that's right. Then the particle is this one, I'll say to 0, because we set it at the origin originally, plus the original velocity, t. Why do I have t next to original? There shouldn't, oh man, I messed up. Well, it's still right, just you don't have to have in parentheses t next to original because t equals 0. Oops. Okay. Fixed. Just there's going to be a big gap now between stuff. 1/2 APT squared. Okay, so let's set these equal to each other. Rm to Rp. You get H plus VMO T plus 1/2 AM T squared equals 0. I'm just going to leave the 0 in there. Velocity of the projectile initial plus 1/2 acceleration of the particle t. Now we already defined a particle to equal a monkey. So gone, gone. Now velocity of the monkey, gone. 0. It's not, it's just let go and then it falls. So we end up with h equals the initial velocity of the projectile vector, of course, times t. That's it. And then you can, I mean, if the question is, at what time does the particle hit the monkey? Boom, you already have it. Just solve for t. All you need to know is the initial velocity of the projectile and how high the monkey is. That's all. It's the only thing you need to know. Now there might be more complex questions, which I'll go into a little bit. But this is the basis for this specific equation. Now this works only when your original velocity is pointing at the target originally. So they're following at the same speed, they'll collide, they're lined up perfectly. So it might be applicable to other situations, but just be careful applying to other situations. Okay, I think that's what I had for that part. Now, what if we have a question that asks, so we have gravity, we have all these stuff. There may be a question that might be slightly tricky because you'll be given a lot of stuff, but then the question will be, at what angle does this need to be to ensure that you hit the monkey? So you're like, okay, well, I have the velocity, I have all the gravity, I bet I can solve for it somewhere, and then I just say stop. Every single shoot the monkey equation is set up exactly the same. You have a D, you have an H, and it's pointed directly at the monkey. So the angle will always equal tan inverse of H over D. Boom, angle, done. So if you're given a ton of stuff and they're saying find the angle, well, all you need to know is the height and the distance away. That's it. What if the question is, let's see, what was my other question? Oh, what if the question is at what time, I think that was my question. Yeah, what time would, so once again, this is not with a given initial velocity or anything. It's just saying, what time would it take for the monkey and the projectile to hit at the exact same time when they're at 0? So right when, kind of like what happened in class, The squirrel hit the ground, the projectile hit right at the same time. What if that was the question? So you can look at some of these and you can be like, well, we want the monkey at some time t to equal 0. How could we solve for that? Okay, well, we can use this equation. Let me make sure I'm doing this right. So we can look at the time it takes for the monkey to just free fall. T equals, I won't jump too many steps. So we set it to equal to 0. We get 0 equals h plus VMO plus OT plus 1/2 AMT. Well, this is 0. Bring the h over. So get negative h, negative 2h over a acceleration of the monkey square root. This is supposed to be squared. Equals t. Okay. But we have to make sure the velocity matches up with that. So all you can do is you can just plug the t in here. This t right here. Plug it into the velocity equation. Figure out what the velocity is. You can figure out what the initial velocity is. I mean, there's lots of ways you could set up this problem. See, the only issue is I don't know how Jason would use this problem. There's multiple different ways he could do it. But if you have the equations, you categorize the problem correctly, you throw all the equations in, you should be able to figure it out. I mean, I just derived these equations from the normal kinematic equations. I just made assumptions like this equals 0 and that equals 0 and things like that. So make sure that when you're categorizing the problems, you do so correctly. Yeah, other than that, I don't want to spend too much time on this, so we can spend time on homework questions. But other than that, are there any questions about Shoot the Monkey? Went over a ton of different methods and ways you could do this. Okay, well, I'll leave it up for now in case people are still writing. Okay, so we have 25 minutes to talk about homework questions. This could be homework 2, homework 3, homework 4. Nothing past 4. I don't think that's even on there yet. And I doubt, maybe you guys are smart and have already started homework 4, I don't know. But we can open it up to questions. Does anyone have any questions right now for any of the homeworks or any of the assignments? Yeah.
On homework 3, it's a circular motion problem.
Okay.
And we haven't actually covered that.
And that's due Friday morning, right, before class?
Yeah, isn't chapter 3 supposed to be just vectors?
Yeah, it should be, yeah.
But we have a circular motion.
So it's like a skater glides along a circular path with radius less than 5 meters. I don't know what it is.
Okay. So, it might be, I think it just might be confusing because it's kind of polar, but let's see if we can do it without getting too much into rotational stuff. Sorry if I'm erasing this and people haven't finished. It will be on YouTube later, so. Okay. Get rid of the monkey. Okay, so it says that a figure skater, I'm not going to draw a figure skater, and pretend that's a circle. It is, what was the meters it gave you? 26? That's big.
4.7.
Okay, 4.7. I was like, wow. Okay, it says radius of 4.7, right?
Yeah.
And then it says, if he coasts around 1/4 of the circle, find the magnitude of displacement vector. So let's say he's here. He coasts 1/4 around here. The displacement vector is this, right? So isosceles triangle. I don't remember the rules for this. We have 4.7 here, 4.7 here. You can figure out what that side is, right? That's all. I think that's all that one's asking. So you don't really have to do anything with rotational, just displacement stuff, just straight lines. Yeah, it's probably confusing how it was asked.
So mine has halfway around, it's like,
So that's just the diameter. Yeah, you got an easy one. Oh, and then it asks how far the person skated. So that would just be the arc length of this. And you probably covered arc length before. It's simply R, so arc length equals R theta, where theta is in radians. That's your arc length, I believe. So you might want to fact check me on that one.
yeah.
Okay. And then the last problem, what is the magnitude of displacement if he skates all the way around the circle? Everyone know how to do the circumference of a circle? Okay. So I think it looked more daunting than it actually was, but yeah, I don't think he would give anything too.
So the arc length is 4.7 times 90 degrees?
Radians, so pi halves. Yeah. So that would be, anyone, a human calculator in here? What's pi divided by 2? To 10 digits. No, I'm just kidding. It's, yeah, 1.7 or something, 1.6 something, somewhere around there. So yeah, it should be bigger than the actual radius, but not double. Okay, any other questions? Homework 3, homework 4, homework 2, 2.1, 2.2, yeah.
Would it be all right if we went over problem 1, chapter 3?
Problem 1 on chapter 3, sure. Okay, I'll do it over here. 2 points in a plane have polar coordinates. Okay, if you remember your polar coordinates, have coordinates 2.7 meters, 30 degrees, like that. Let's assume that's 30. And 2.7. And they all have 3 sig figs. So 30 degrees, 2.7, that's what I'm given. I don't know if it's the same for you or not, probably not because it's red, so it probably changes. And 4.3 meters at 100 degrees. So up here, 4.3, and this is 100 degrees. Determine the Cartesian coordinates of these points. So this requires some trig. Cartesian points, x equals r so katoa. There we go. Sine theta. Y equals r cosine theta. So for x1, y1, this would be theta 1, r1. 2.7 meters times sine 30 degrees. And then similar there, x2. So this one might be a little bit tricky because you're actually going to go from the 90 degree mark and then just do 10 right there. So you still have a triangle.
What was that number that you wrote? That small number right by the 2.7 in the circle?
Right there. Oh, meters?
Left? What was that?
Oh, that one 100. That's 100 degrees.
Oh, okay.
That's just what I was given on my example one.
Okay.
So if it's past the 90, you'll make a triangle by doing it at 9. And then you'll just have to realize that you're on this line. So the x would be negative the y would be that direction. But should still be able to do it just the same. Should still be able to get a direction there. The only difference is that if you do it this way, your y and x will swap as far as cosine and sine, because you're adding 90 degrees. So they just flip. Does that make sense? Okay. Yeah, I'm not gonna solve them though. Any other questions? Question. 8 on 3. Two vectors A and B have precisely equal magnitudes. In order for the magnitude of A and B to be x times larger, depends what it says for you, then the magnitude of A and B must be the angle between them. I need to make this bigger. Okay, two vectors A and B have precisely equal magnitudes. So they might be going different directions, but I'm just going to draw them straight. This A, B, they have the exact same magnitudes. And it says, in order for the magnitude A plus B be 120 times larger than the magnitude of A minus B, what must the angle between them be? So the magnitude needs to be, so let's say you have an angle like this, and then, oops. It'll go like this. This would be maybe a plus or a minus. If it was minus, then you would just flip it. It would go like that. So it's saying, how would the magnitude here be 120 times bigger than the magnitude here? Something like that. And then it's asking for the angle. What must be the angle between them? Between the plus. So this one right here. So it's going to be a small angle. Now, let's see, how much do I want to tell you? A plus B magnitudes equals x A minus B. Similar to that. Now, the angle, let's see, the angle defined between two vectors. A plus, shoot. Okay. Let's do this. I'll give you some. So let's say this is A, this is B, this is negative B. Oops. Mine says that what angle do you have to make a vector, right? Not magnitudes. A vector equal to 120 times the larger than the magnitude of A minus B. 120 times larger, so this side, than A minus B. So, the angle between them, you're testing my trig. The angle between them is A plus B over Okay, does anyone have that in front of them? I don't want to look it up in the book. The magnitude of angles. It's an equation of A plus B over B, E. There we go. A plus tan theta. Yeah, it's in section 3.4. So the tangent theta equals Ry, or R1 over R2 equals A1 plus B1, A2 plus B2. Now in this instance, A1 equals B2, B1 equals negative B2. So you should be able to find the angle, oh, and then you have to times it by 120 for the minus 1, which is on the bottom. 120. That was mine, 120. A plus B over 120, A minus B, and then theta equals tan. There's a light switch right here. A minus B, like that. I think that should be it. If not, I switched something slightly, but I shouldn't have done that much of the problem for you anyway, so enjoy. But yes, that is equation 3.17. That looks at the angles between two different vectors. Hopefully that works. Does that help at all? That didn't help?
What is, we don't know any A and B, so how do we find it?
Oh, you mean this right here? So, yeah, I think I did it wrong. A plus 120 times plus, I'm pretty sure one of these are supposed to cancel. Just a sec, let me look real quick. Does my calculator have tangent inverse? Okay. Equals, oops, tangent inverse. Okay, and then that one, 120, 90 minus. Okay,
Is that this one over there? After that?
Yes, tan inverse. So the equation is this, tan theta. So I can get the problem by canceling it out. Let's see, 90 minus. One divided by 120. So I would recommend taking a look at that section of the book, mainly because I can't do the trig functions very easily right here. Tan inverse, that, and then 120, tan inverse. Huh. You know what, I think I'm just doing this wrong. So, should we go a little bit more in depth? Does anyone have any other questions? I go a little bit more in depth into this one. Okay, I'm going to answer some of these questions and I'll come back. Okay. No, you already went. What? You got a question? Which one do you? 10 on 3? Paper problem. Okay, I'm not going to give you very much of this one since it is a paper problem, but I will describe some of it. Oh, I just realized something about this problem. That will help you, give you a hint. They're the same size, the vectors. Okay. I just realized that. I was like, oh. Okay. As she picks up her rider, the bus driver traverses 4 successive displacements represented by the expression. And there's an expression with I hat, j hat, I hat, j hat. Oh, it's giving you the direction. So it's saying it's going this direction, then it's going some angle, so minus cosine 40 minus 2. I'm gonna get the angle wrong with that, so I'm not gonna do it, but it's I hat still. So it's I hat, this is negative j hat, positive I hat. Okay, sorry, I'm doing I hats as y. Okay, here we go. Okay, negative I hat, negative I hat, negative j hat, positive I hat, negative j hat, negative j hat. Okay, here B represents one city block. Okay, so all those are unit, you can say unit 1. A convenient unit of distance of uniform size, I is east and j is north. I is east, j is north. Okay, I think that's what I did, because there's negative, negative, that. Oh, draw a map of the successive displacements. Well, that kind of gives you a hint of what it will look like. The only difference is that mine are guesstimations, they're not actual values. What total distance did she travel? Just add up all those individually, compute the magnitude, and then you just see the beginning and the end point. So the total distance traveled is all these added up, independent of if they're negative or positive or anything, then the magnitude is just that to there, which you can do by adding up all of the i's, all of the j's, and then Pythagorean Theorem. Because you'll be left with a vector of all these added up, which will be this, and then you can do Pythagorean Theorem, and it will give you total I, total j. You can figure out what the magnitude is.
On mine, it's giving some polar coordinates and others are not.
Yeah, so it's giving cosine. So the thing I didn't want to include is the angle, but it's I hat, so it's not actually an angle. Does that make sense? So if you are doing, at least, I gotta be careful here, because I think this is what he's doing, because it's in parentheses and then it says I hat. So everything in the parentheses is in the I hat direction.
Okay.
So he says 2, for me it's 2b cosine 40 degrees. And then that whole thing is in the I hat direction. So
East. So right.
once again, I think this is what he's saying. I wish I had access to him right now, but if this is positive, which on me it's not, it's negative, that would be west, but this would be your number, your magnitude west. But I only think that's the way it is because it's I hat right here. It's not, if there was no I hat, cosine of 40 would be telling you a direction. Let's see, if he did it that way, no, he wouldn't do it that way. That'd be too difficult, I think. Yeah, main east, west, and north, south streets. Oh, it's in the description. The displacements of 40 degrees and 50 degrees represent travel on roadway in the city that are at these angles to the main east. Okay. So it is an angle. I should have read the description. So the first one, this way, and then it's negative cosine 40 from the east. I hat, so it's I hat cosine 40. J hat sine negative sine 40. Okay, I'm not going to do too much for you, but just know that when it has a j hat, you're doing it from the up and down direction. When it says I hat, you're doing the angle from this direction.
So you're starting your angle from
With respect to the
Exactly.
I hat, or with respect to the j hat.
but is there a way for you to tell whether it's in like the third or first quadrant?
So all of the j hats will be sine, all of the I hats will be cosine, because of that same thing that we went over here. This is reversed when it's up here, different quadrant. So it's coming from a different angle, and that's cosine. Yeah, I don't know how much I want to tell you because that, I don't want to say it's straightforward, but I feel like this one is to test specifically what you've learned throughout there. And yeah, just know that the angles, it's traveling along streets and the streets have angles, but only where they show cosine 40 or sine 40 or cosine 50, sine 50.
Okay.
I don't want to give too much away. And just think about what sine 50 is, what cosine 50 is. Think about that.
And the ones that don't give an angle, it's just straight then?
Just straight, yeah. Absolutely. Okay, I know there was another question. We have 3 minutes. Yes?
What was the place you go for help? What's the room number?
309. The only issue is that this semester there's only 4 TAs, me not included, so there's like, I think 6 or 7 total hours during the week that there's actually a TA in there. You might be able to get help in the think tank. I think there's like also schedule for when there's tutors in there. But yeah, 309. And the other issue is that a lot of TAs in there are doing homework themselves, so they don't want to be bothered. That's just, Jason keeps saying, go to 309. They hang out there. They want to answer questions. No, we don't. We have so much homework that it's just ridiculous. We only want to be there when we have to be.
It's better to go to the think tank because they're paid to.
Yeah, think tank is better because they are paid to be there. Think tank. It's in Jeb.
Area.
What room is that in?
Think tank? I don't remember. So from your classroom, you look up the stairs. So if you're looking at the classroom, you look up the stairs to the right. You go up the stairs towards the bathrooms. On your left is the think tank.
It's literally just the glass room.
Yeah, it's the glass room. Okay. Any other questions? There probably are, but we're running low on time. If you do have questions, you can come up here and ask me, and I'll try to answer them for you.